Okay, so I decided to add a lesson in this chapter because we did cones, cylinders, and spheres, volume, and then we did surface area of cylinders and cones. So I thought it was appropriate to do surface area of spheres as well. So name and date at the top. Earth is so large that it is reasonable to assume that area formulas for plane figures, rectangles, triangles, and circles to find the areas of most small land regions. But to find Earth's entire surface area, you need a formula for the surface area of a sphere. Now that you know how to find the volume of a sphere, which is 4/3 pi r cubed, you can use that knowledge to arrive at the formula for the surface area of a sphere. So, the volume of this, or the surface area of a sphere formula is 4 pi r squared. There would be 4 circles that would fit on a sphere, and we will watch a video on that when we're in class. So all we need to know is the radius. So here we have the radius here, no label, so we'll label it units. So it's 4 pi r squared, 4 pi 9 squared. Typing that in our calculator, 4 pi 81. We get, round to the nearest, oh, it says all measures in centimeters. The nearest 1,117.9 centimeters surface area squared. Plug and chug. Again, labels in centimeters. So this one's not giving us the radius, it's giving us the diameter. So the radius is half of that. Half of 18 is 9, this is 0.9. So we have surface area is equal to 4 pi r squared, 4 pi 0.9 squared. Type it in our calculator, 4 pi 0.9 squared. Make sure we have that correct. 10.2 centimeters squared. We could leave this in terms of pi and have, if we wanted to do that, just as a reminder, 0.9 squared times 4. This would be 3.24 pi. In case we ever need to leave it in terms of pi, there's a reminder. This one we have half of a sphere. So the surface area is going to be half of 4 pi r squared, which I'm just going to simplify that to 2 pi r squared. 2 pi 12 squared. 2 pi 144. 904.8. Now we could have found the whole thing and then just divided by 2 at the end. That would have been fine too. Little cultural connection here to spheres. It says a wigwam was a domed structure in the Native American woodland tribes such as the Kickapoo, Iroquois, Cherokee used for shelter and warmth in winter. They designed each wigwam with an oval floor pattern, set tree saplings vertically into the ground around the oval, bent the tips of the sapling into an arch, and then tied all the pieces together to support the framework. It's a lot of work. It's pretty awesome. They then wove more branches horizontally around the building and added mats over the entire dwelling, except for the doorway and the smoke hole. So here's probably a doorway, and then somewhere in there they would have their fire in there to keep their families warm. So applying that, it says assume a Kickapoo wigwam is a semi-cylinder, so half a cylinder in the middle, with a half hemisphere on each end. The diameter of the semicircle in each of the half hemispheres is 3.6 meters. The total length is 7.6. What is the volume of the wigwam? So this is, this one says what is the volume and the surface area. I'm more concerned with surface area, so we're going to work on that. So we have to remember the surface area of a cylinder. Well, that surface area was 2 pi r h plus 2 pi r squared. This means the whole outside, and this means both circles. But we don't need either circle, so we're not going to need that. And we only have a half cylinder, so we could take this divided by 2. But I'm just going to get rid of that. I'm just going to get rid of the 2. So now we can plug that in if we know that for the cylinder. And then we have hemispheres, or quarter hemispheres. So it's really like we have a whole hemisphere up top, but it's cut in half. So They're equal, so we can think of it a couple different ways, but I'm going to write in here that we have one hemisphere. Because if we were to put those two things together, we would have a whole half. And that surface area is going to be half of 4 pi r squared. Okay, so now we can plug in what we know. Pi, the radius of the cylinder. Well, they said it's 3.6 from end to end, so divide that by 2. We got 1.8 for the radius. 1.8 times the height of the cylinder is 4. And then we didn't have any circles, so we can add our hemispheres. So we have half of 4 is 2 pi, the radius again, 1.8 squared. So if I take pi times 1.8 times 4, 22.6 for my cylinder, plus 2 pi 1.8 squared, 20.4 for my hemispheres, or my quarter spheres, together. And so we add those together, and we get 42.43 meters squared. Again, just worrying about the surface area. Okay, some more real-world problems. It says that a farmer must periodically resurface the interior, the wall, the floor, and the ceiling of the silos, I guess, to protect it from acid created by the silage. The height of the silo to the top of the hemispherical dome is 50 feet. So from the ground to the top is 50 feet. The diameter is 18 feet. So from here to here. So we're going to have to figure some stuff out here. What is the approximate surface area? So we have the height of the silo to the top of the dome is 50 feet. All right, so we have a cylinder, plus we have a hemisphere. Again, thinking about the surface area of a cylinder. Now it says we're going to cover the wall, the floor, and the ceiling. However, we're covering the ceiling of this, so we're not covering the ceiling here. So we have a lateral area, 2 pi RH, plus we're only going to cover this circle on the floor, so that's only 1 pi r squared. The hemisphere, we have half of 1, so half of 4 pi r squared. So let's plug in what we do know. We can bring the 2 down, we can bring the pi down. The radius we know is going to be half of 18, so 9. The height of the cylinder. Now we have to be careful here because we've got 50 from here to here, but the height of the cylinder is going to be taking this off. Now remember, a sphere has a radius all the way around. So if the diameter is 18 from here to here, then that means that in my hemisphere, this portion is 9. So we have a 9 for our hemisphere, and then 41 for the height of the cylinder. Plus pi, now we know it's 9 squared, and we can put all these together. Half of 4 is 2 pi 9 squared. So just for the cylinder, 2 pi 9 times 4 plus, I'm going to do 81 pi. That's 480.7. Now the hemisphere, 81 times 2 times pi, just kind of did things out of order there, 508.9. If we add both of those together, we get the surface area to be about 989.6. 989.6 feet squared. So they said, well, if 1 gallon of resurfacing compound covers about 250 square feet, how many gallons would we need? So what are we going to do with these numbers to figure out how much we need? We're going to divide them. So we take our 989.6 feet squared, and I'm going to show you doing that dimensional analysis again. That would divide because we want our feet squared to go away. And that's why it ends up being a division problem. So 986.6 divided by 250, We're going to need 3.5. They don't sell half gallons. So we're going to need to buy 4 gallons. Okay. Now, one more problem with the silo. There is 0.8 bushels per cubic foot. Calculate the number of bushels of grain. So cubic feet is a volume problem, so we can quickly do this one. The volume, just as a refresher, this is volume now, not surface area. The volume of a cylinder is pi r squared h, this is my cylinder, plus the volume of a hemisphere, hemi, is 4/3 pi r cubed, but then half of it. So now we have all the information we need from the previous problem. So it's pi 9 squared. Height of the cylinder was 41 plus half of 4/3 pi. Radius is 9 cubed. So we've got pi times 9 squared times 41. Large number. 10,433.2 plus, so I'm going to do 4 pi times 9 to the third divided by 3 and then divided by 2 because this is the hemisphere. 1,526.8. Adding that to my 10,433.2, I get 11,960 feet cubed, and a bushel can, there's 0.8 bushels per cubic foot, so if I multiply by 0.8 bushel per cubic foot, I'm going to see my labels cross off, take this times 0.8, and I get 9,568 bushels. Is what I can hold, roughly. A newborn kangaroo is small enough to fit in a teaspoon. Have a great day.